and it's our privilege to host your session. We know that your session is so important for us because my students are going to utilize each and every minute of this session. We are going to learn many interesting facts about the rocks. So before we start the session, could you please introduce yourself?
Absolutely. So first of all, it's really a great pleasure to join everybody today. I've never been to India, so I'm really excited to have this window to where you guys are right now. But my name's Ethan Baxter. I'm a professor at Boston College, which is in Boston, Massachusetts, in the United States, right on the east coast of the United States. And I'm a geologist, and the kind of geology that I do really focuses on the stories that rocks and minerals can tell us about the Earth's past, about its present, and sometimes even about its future. And the other thing I'll tell you about the kind of research that I do is it involves chemistry. And I'm wondering if any of you guys are interested in chemistry or you've started studying chemistry. But I do something that we call geochemistry, which is chemistry of the earth, chemistry of earth materials. And maybe we'll talk about some of those things today. Yeah, so that's a little bit about myself.
Thank you so much for introducing. And my students, they study the chemistry and physics as part of their curriculum.
Okay.
But not geophysics.
From P.H.S Ilavaram. I am so glad today to interact with you. I am so interested in the study of rocks. I am super lucky to ask a question. Here my question is, how many different kinds of rocks are there?
Yeah, so that's a really interesting question. I'll answer it in maybe two ways. The first way is that, as you probably know, rocks are made of minerals. So rocks are basically a mix of a bunch of different types of minerals. We can look at some later on in the session. So if we talk about minerals, which are those ingredients of rocks, there are over 4,000 different types of minerals. So that's a number to remember. It's probably, we discover new minerals every year. So it's probably coming up towards maybe 5,000 different minerals. So if you think of it that way, and if rocks are made out of minerals, oh my gosh, you could make so many different types of rocks out of those different minerals. So I think, in terms of minerals, we can think about that 4,000 number. In terms of rocks, it's almost infinite, the number of different combinations, but we like to break down the types of rocks into some different categories. And I'm wondering, have you guys heard about the difference between igneous, metamorphic, and sedimentary rocks? Does that ring a bell? Those are the three fundamental different types of rocks that we talk about. Those that are born out of fiery magma and lava, igneous. Those that are born out of broken down sedimentary particles, which we call sedimentary. And those that are anything else that's been squished and transformed over time. And within those three categories, there's a whole bunch of different varieties. But I would say that the good number to remember is over 4,000 minerals. That's the incredible variety that we have on planet Earth. Good question.
Thank you so much, sir.
You're welcome.
Good evening, sir.
Hi.
This is Bushra, an 8th grader from P.H.S Ilavaram. I'm extremely happy today to interact with you. I would like to ask a question. What is the biggest gem in the world?
The biggest gem in the world. That's another really fun question. I'm sure I don't know the answer because there have been so many found over hundreds and thousands of years that people have been exploring and looking for gems. Some of the most famous gems that I can think of are diamonds. And I think you guys might have some other questions about diamonds later on, but the most famous diamond, certainly in the United States, is a diamond called the Hope Diamond. the Hope diamond. And it's a fun one. Later on, you could Google that one or check it out online. But it's probably about this big. It's really enormous. And the other thing about the Hope diamond is its color. Do you know what color? Any chance?
Oh,
No, sir.
It's blue,
oh,
which is incredibly, incredibly rare. Most diamonds aren't blue, but the Hope diamond is huge and blue. And it's in a museum in the United States called the Smithsonian Museum. I saw it once and it was magnificent. But there are so many other different kinds of gems. Rubies and emeralds can get large. Aquamarine, um, which is a beautiful light blue mineral, that can get very large as well. But the largest one of all, I couldn't say. I will mention, I think you guys have maybe heard of or seen some of my YouTube channel videos.
yeah. We have.
There's one of those videos that I'll mention. It's episode number 12. It's called Crystal Cave. It's not about gems, so it's not exactly your question, but this episode, the crystals in this cave, I don't have a picture of it with me right now. They are about as tall as 4 people standing on top of each other. So they're probably like 30 feet long in this cave. They're unbelievable. And that'll be a fun episode. If you want to see big crystals, that's a good one to see. So I hope that answers your question. Great question.
Thank you, sir.
You're very welcome.
Good evening, sir. This is Asha Rani, an 8th grade student studying at P.H.S Ilavaram. I am honored today to be able to interact with you. I have a question. My question is, can diamonds melt?
Right. So the answer is yes. But the question is just how hot do you have to get the conditions for a diamond to melt? It turns out that to melt a diamond, you'd probably have to heat it up to about 4,000 degrees Celsius. 4,000. You have to go to like the center of the earth or to the sun, to a star, to find temperatures that are that hot. So just about any substance will melt if you get the temperature high enough. The pressure also makes a difference, how much you squeeze it. And actually, diamonds like to be squeezed to very, very high pressures. So if you take away the pressure, it's actually easier to break it down. But what happens, I'm curious if you know, if you were to take a diamond, like one that we're fortunate enough to find at the Earth's surface, lucky enough to find at the Earth's surface, it's not really stable. It's an interesting thing about diamonds. They really prefer to be deep in the earth where they're squeezed tight. When they're up at the surface, they would like to break down. So if we took a diamond right now, if anybody happens to have a diamond, and you heated it up, not that high, maybe even 600 or 700 degrees Celsius, it wouldn't melt. But do you have a guess what it would turn into?
No.
Yeah, it wouldn't melt, but it would turn into another mineral called graphite. And I have a guess that right now in your classroom, there's graphite, because graphite is what's in pencils. So the graphite tip of the pencil, exactly. Yep, exactly. So the black pencil, we used to call it pencil lead, but that's actually graphite. Graphite is exactly the same as diamond. It's made of the exact same thing. It's pure carbon and nothing else. But the way that the carbon is arranged at the atomic scale is very different. Graphite is very soft. That's what makes it, such a great pencil that rubs right off on your page, whereas diamond, as you know, is extremely hard. So if you heat diamond a little bit at the Earth's surface, it turns into graphite. If you go to 4,000 degrees, it will melt. But it's interesting because that makes diamond one of the not just hardest materials, it's a mineral, but one of the most durable and resistant materials. Some of the oldest things that we know of in the solar system and in the galaxy are teeny tiny little diamonds that have survived all the incredible processes in history that the galaxy has experienced. So diamonds are extremely special scientifically. Great question.
Thank you so much, sir.
You're welcome.
Good evening, sir. This is Bhavya. I am an 8th grader from P.H.S Ilavaram. From P.H.S Ilavaram, it's my pleasure to ask this question. My question is, why are rocks so hard?
Yeah, so that's a question a lot of people wonder about, and with the conversation we just had about diamond, it's a good place to talk about that. Let me answer this in two ways. So the first way that I have to answer it is to say that not all rocks are hard. I've got a bunch here. Maybe this might be a good time to take out one of the rocks that I have. This one right here is something called chalk. I bet you might have some chalk in the classroom as well. But chalk is very, very soft. I can even take my pencil here and scratch away at it. Or it's hard, I guess it's hard for you to see. But chalk, it rubs off on your fingers. There you can see my fingers are kind of white and chalky. So not all rocks are as hard as you might think. Something like diamond is extremely hard. So the question I want to sort of return to is not so much why are all rocks hard, but why are some rocks hard? Why are some minerals hard? And why are some minerals soft? And that actually goes right back to the last question about diamonds. So diamonds and graphite. Diamond, as we said, is made out of carbon. But the carbon atoms, which is, maybe you've learned a little bit about this in chemistry, the carbon atoms are arranged in a very strong structure. So it's like if you had a bunch of building blocks, depending on how you arrange those building blocks, you might make a really stable structure, or you might make a really weak structure. In graphite, the carbon atoms are arranged in a very weak structure. They're very easy to break down, and that's why graphite's extremely soft. You can rub off the pencil lead on your hands. Diamond, it's completely different. So it has to do with the internal atomic structure that different minerals have. Do you know what the softest mineral is? Diamond is the hardest mineral. Do you know what the softest is?
No.
Yeah, I have some. So the chalk that I brought is pretty soft, but there's something even softer than that, and it's this right here, which again is probably hard to see. It's a beautiful mineral. It's kind of got a greenish color to it. This mineral is called talc. Talc. And it's so soft, it comes right off in your fingers and almost leaves like a greasy feel. People use talc. They make it into a powder, and it makes things very smooth. So you can put it in machinery, for example, to lubricate gears that might be rubbing by, using that very, very soft talc. If we had more time, and if I had some models with me, I could show you some of those structures, but that's the best way I can answer that. So some rocks are extremely hard, some minerals, others very soft. Very interesting question. We're really getting into the properties of minerals at the atomic scale when you ask that question.
Thank you, sir.
You bet.
Dean sir.
Hello.
This is Shahina. I am studying class 8, and I am privileged to be with you today, sir. I want to ask a question, sir. My question is, if diamonds are strong, what is the second strong?
What's the second strongest mineral? Yeah, so that's a fun question too. So remember, with over 4,000 different minerals to choose from, there's a whole bunch on that list. But in terms of minerals that are more common that we think about, there's something, and this might be interesting to some of the other questions as well. There's something that we like to talk about in the study of minerals, which is called a hardness scale. And it goes from 1 to 10. I'm not sure if you've heard about this hardness scale before, but 10 is the hardest of all. And that's diamond. There's nothing harder than diamond. It's on the top. 1 is the softest, and that's this talc that I showed you guys just before. Second place, right below diamond, at number 9, is a mineral called corundum, which you probably haven't heard of, corundum. And it's extremely hard. But what that means is a lot of times the really hard minerals are the ones that people like to collect as gems. So someone was asking about, gems and what's the biggest gem. If you're lucky, corundum, which is extremely hard, has a hardness of 9, can have a little bit of a chemical impurity, a little bit of an element called chromium inside of it. Just a little bit of chromium. And a corundum that has a little bit of chromium takes on a brilliant red color. And when that happens, we call it ruby. So a ruby is a brilliant red corundum, and that is the second hardest mineral. And sometimes corundum has a little bit of iron as an impurity. And when corundum has iron in it, it takes on a rich blue color. And when that happens, we call it sapphire. So the answer to your question is rubies and sapphires are the second hardest mineral after diamond.
Thank you, sir.
You bet.
Good evening, sir. This is Monica, an 8th grade student from P.H.S Ilavaram. I feel proud to interact with you. I have a question. My question is, what makes certain rocks valuable?
What makes them valuable? So that's a really interesting question because there's so many things that can make rocks valuable. And I think, for a lot of people, you might see a rock outside and you might wonder what's exciting, what's interesting, as your question is, what's valuable about a rock? And I think the best way to think about that is to think about 2 things. What do people need rocks for? And 2, how hard is it to find that particular rock? So a diamond or a ruby or a sapphire, which we've just been talking about, people like those because they have beautiful colors, they're sparkly, and they're very hard. And so they're great for jewelry and necklaces and things like that. And they're really hard to find. They're very rare. So something like that, very sought after for its beauty and very rare, makes it extremely valuable. But there's a lot of other things that make rocks valuable. And I've got, let me show you another example right here. This is an interesting one. I'm not sure if you can see it's got a pink color to it. Actually, on my computer, you probably can't see it, but this pink color is almost the same as all of your shirts that you're wearing, all the girl shirts. It's a very rich pink color. And this is a mineral it's got a strange name. It's called spodumene. I don't think anybody would have heard of spodumene, but I'll tell you, this is becoming one of the most valuable minerals on the planet. It didn't used to be so valuable, but these days we're starting to need more and more of this stuff because this mineral called spodumene, this pretty pink mineral, has an ingredient inside of it called lithium. And I'm wondering if you've heard of lithium before. Lithium is an element, a chemical element. It's loaded, lithium is loaded up in this mineral. And we need lithium to make batteries. So a lot of the energy storage solutions that are being looked at in society today, in our technology, anytime we need to store energy, whether that's storing energy from the sun in powerful batteries or in electric automobiles, or even in something like a phone, those batteries require lithium. And so we have been mining and seeking lithium resources like this all over the world in order to make those solutions for energy storage, batteries. So that's a completely different example of what makes something valuable. Fortunately, lithium and ores like this are a lot more common than diamonds and rubies and sapphires, which is good because we're needing to mine a lot of lithium resource to create sort of this new energy storage future. I hope that was a useful answer for you, but it's a great question because there are so many different things that make the resources of the earth valuable to society, valuable to people. Great question.
Thank you so much, sir.
Welcome.
Good evening, sir. This is Swati. I am an 8th grader from G.P.H.S Ilavaram. I am so delighted to interact with you. I would like to ask a question. Why are some lava rocks red and others black?
Yeah, so I've got a nice piece of lava rock right here, and this one is black, mostly black. It does have, can you see right there on the bottom? It's got a green thing in it too. We can talk about that green thing maybe a little bit later, but yeah, this is a typical lava rock. This one I collected on the island of Hawaii. Do you have lava rock near where you guys live?
No, we don't have.
None there. There are some places in India that we might talk about later. I know you guys are on the east coast of India, if I found it right.
Yes.
Yeah, on the west and central part of India, there's some really, really important former lava rocks. But this one is black from Hawaii. But you're absolutely right. Sometimes you can find red colored lava rocks. Sometimes I've seen white colored lava rocks. The other one that I have right here is a lot bigger, is this one. And this one does have a little bit of a reddish or a brownish color. Now there are black spots in it. See all the black spots? So I'll answer the question in a couple ways. First of all, in general, any rock or mineral gets its color based on the ingredients inside and the conditions under which it was created. So certain ingredients like things like iron or carbon that we've been talking about can change the color of things. But even the same ingredients at different conditions, like remember we talked about the diamond and the graphite, diamond can be clear when that pure carbon is really squeezed, but that graphite is kind of silvery black at different conditions. In those volcanic rocks, the color, the difference between the black and the red really has to do with iron and oxygen. And this is what's kind of cool. This rock here, the black one, it's loaded with iron. There's lots of iron in this rock. But when this thing erupted, it didn't have the time or the conditions for the iron to react chemically with the oxygen in the atmosphere. And so it stayed black. Other rocks, either upon eruption or more likely after they've been exposed to the weather, to the elements, to the rain and the air for a long time, the oxygen in the air combines with the iron and turns it that red rusty color. Have you heard of rust? Red rust?
Yes. Yes.
Yeah, red rust. If you take an old, a piece of iron or a nail or anything like that that's made out of metal iron, leave it outside for a couple days or 100 years, it'll start to turn red. That's exactly what can happen to lava rocks. It's that iron reacting with the oxygen and turning red. I'll show you one other rock that I brought, which is this one. Here's a pretty red color right there. That is not lava rock. That's a sedimentary rock that I collected in France. And this is something called ochre. And this goes back to the last question about what makes rocks valuable. This was a very valuable rock, hundreds of years ago, because this brilliant red powdery rock was used for paint. And this is almost entirely iron, oxygen, and a little bit of water mixed in there too that gives it that brilliant red color. So two things, both have iron. This one didn't really get a chance to react with oxygen. This one did, and that's what causes that difference in color. So just by looking at something as easy to see as color, right? You don't need fancy microscopes to see a difference in color, but you can learn a lot about the chemistry and the ingredients in the story of those different rocks just based on the color. So that's a really great question and a great observation to make. Thank you.
Thank you, sir.
You're welcome.
Hello, sir.
Hello, how are you?
This is Samsaro, and I am fine, sir.
Good.
This is Samsaro, an 8th grader from P.H.S Ilavaram. I am so glad to interact with you, sir. Can I ask one question, sir?
Please.
How do rocks form in the ocean?
In the ocean. So the ocean is such an interesting place because it covers 2/3 of the planet, and yet it remains to this day the least explored part of the surface of the earth. Submarines, have gone to the bottom of the ocean, to the deepest parts of the ocean, but there's still very little that we know about what's down there. But we do know about the rocks that are down there. And there are really two different types of rocks that form on the bottom of the ocean. The first type are lava rocks, just like we were just talking about. And I actually have a pretty cool rock right here. This is another lava rock, but this was collected from the bottom of the Pacific Ocean. So a ship went out. This is a friend of mine at Boston College, went out in a ship into the Pacific Ocean, and they basically dropped a giant net. It's a little bit more complicated than that, but imagine a huge metal net with a long cable on it. They dropped it off the back of the ship, and they dragged it along the bottom of the ocean. We call it dredging. They dragged that net, scooped up a bunch of rocks, and this is literally one of the rocks that came up. This is very, very similar to the rock from Hawaii that I showed you. So that's from a Hawaiian volcano. This is from basically an underwater volcano. These are both called basalt. So at the center of the ocean, there's something called the mid-ocean ridge. And it's a long ridge where hot magma comes up and that cools, and then that pushes apart and makes the ocean basins bigger. But that's a critical process that forms the ocean basins and the sea floor on the bottom. The other type of rock that forms in the oceans are sedimentary rocks. Just imagine any river or stream that flows out into the ocean is carrying with it lots of little bits of sand and mud and sediment. And a lot of sediment and fine-grained muds and clays get blown into the ocean. And all of those things settle down into the bottom of the ocean over time. And we also know that there's a lot of life in the ocean, fossils, shells. And a lot of times those shells, even the microscopic ones, they will settle down onto the bottom of the ocean too. Remember this chalk that I mentioned before? This is what forms in the bottom of the ocean. Chalk is something you would find in the more shallow parts of the ocean, not too deep, because of what this is made of. But this is made of something called calcite. And it's mostly old, dead, little tiny microscopic organisms in their shells that have accumulated in this chalk on the bottom of the ocean. So igneous rocks like basalt, and then on top of those, sedimentary rocks like chalk and other sedimentary rocks as well. The ocean is an amazing place for geologists to study, not just the rocks, the water, the vegetation, and all the marine life as well. It's an amazing frontier of research. Great question.
Thank you, sir.
You're very welcome. Part of inspiring me for that. And I have to say, it's not just one person. I've had many, many teachers over the years, many friends who have helped inspire me. I would probably say maybe the person that stands out the most, I'll tell you two people. The first person was my high school teacher. So when I was in ninth grade, and so in the States, that's about 14 years old. You guys are about that age, 14 years old. Is that about right? Yeah. So same age as you guys, my teacher, he was, taught me earth sciences, and he was wonderful because he told us all these incredible stories about the earth. He allowed us to explore our interests and our curiosity. And he had a great collection of rocks, which was also fun for me. The other person that I got to meet when I was actually even younger than that, I think probably when I was about 10 years old, 9 or 10 years old, there was a geologist that lived in my town. So, just down the street from where I grew up. And this person was incredible. He had traveled all over the world. He'd been to India, actually. I know he'd been to India and Pakistan. He did some of his research in your part of the world. He's done work in Africa, and he was an exploration geologist, which means this goes back to our other question about what makes rocks valuable. He was the kind of person who would be hired by a company, and they would say, "We need you to go out and find lithium, or we need you to go out and find rubies." And that would be his job. And so he had stories from being all over the world, and his rock collection was incredible. And he had me over to his house, and he showed me his rock collection, and he actually gave me some of his samples that I still have in my office, my research office at the university right now. So those were special memories of those two people. So yeah, I hope that gives you some sense. Teachers and people that were able to really help me explore my passions, really help me get interested in what I do.
Thank you, sir.
Welcome.
So, yeah, Ethan, we have 5 minutes time is left. In these 5 minutes, I would like to request you to give us an insight on the job opportunities, the career opportunities for someone who studies the rocks.
Yeah. So I would say that these days, the geosciences, so all the sciences that study the earth, whether they involve rocks directly or indirectly, geochemistry, geophysics, environmental science, these jobs are becoming more and more important to the global society, here in the States, there in India, everywhere. And I think some of the things that are driving that have to do with critical resources. There are earth resources that society needs, that people need, that I need, that you need in order to survive, in order to have the kind of society that we've created, the incredible things that we've created on our planet today. But these things require earth resources to be sustained. So when I say a resource, what am I talking about? Well, it could include certain rocks and minerals. We talked about the lithium, for example. I've got some other examples of this rock here, which is another beautiful pink rock. This is rich in something called rare earth elements. Rare earth elements are critical for a lot of our technology. We need people that are able not just to continue to find these resources. This is critical now. We have to find people that can find them and extract them without damaging the environment. That's the big difference. people have been extracting resources for a long time, but I know in our country, there are still places where people long ago went mining and extracting resources, but left a mess. They didn't know how to extract it cleanly and left environmental messes. So being able to find new resources and extract them in a clean and safe and environmentally responsible way, that is critical. Another resource, water. Water for drinking, water for energy. Just having proper drinking water throughout the globe is a critical issue. It's been an issue for a long time, and it remains one. So geologists are part of understanding how do we maintain a proper water supply. And I know that in parts of India, the water supply is a big concern, as it is here in the western part of the United States. And I think the third big area that I'd talk about is energy. As I'm sure you know, most of the energy that the world is using comes from the burning of fossil fuels. I brought a little piece of coal right there. Coal is an incredible resource. That's more carbon, very similar to graphite and diamond. But coal and oil, when you burn them, you unleash energy that's been stored up for hundreds of millions of years. That's an incredible storehouse of energy. The challenge with those fossil fuels is that that's what's contributing to global warming. Too much of that carbon is going into the atmosphere, and that's heating up the atmosphere. So we need geoscientists to find different ways to find energy, to store that energy, to harness that energy. So those are three reasons I'd start with: careers involving mineral resources, environmental stewardship, water resources, and energy in general. And for me, researching all those things in an academic environment as a professor means that I get to teach and share my knowledge with with people like you guys as well. And that's what, frankly, I enjoy. You can always be a teacher.
Thank you so much for your time, and we thoroughly enjoyed this session. All of you say namaste. Thank you so much for your time, and we look forward to have you one more time and with some other new students. So
wonderful.
Yeah, bye for now. Good night.
All right. Bye-bye, everybody.